think we're good to go. All right. Thank you so much for everyone who are joining in for viewing this session. I'm really excited to be presenting for the second time in this year itself at Hack the North for a workshop. And the topic for today's workshop is machine learning for mobile and web using MediaPipe. And we'll be today understanding what exactly is MediaPipe and how can you use it to actually create very simple but yet really powerful solutions, specifically machine learning solutions when it comes to mobile development or web development, and how can you get started and actually build a project at Hack the North as well. So we'll be covering today about what exactly is MediaPipe, how can you use it, what are the different use cases and examples that where it's been used in real life, and how can you also try to implement a simple solution with just a few lines of code and not really having to know in-depth knowledge about machine learning. So with that in mind, let's get started. So, hello everyone, I'm Shivai, and I'm currently a Google Server of Code at MediaPipe and TensorFlow, and I was previously a workshop lead for a session on TensorFlow.js at Hack the North Plus Plus. So you can connect with me on my Instagram at ShivEnigma and on my Twitter at HowDevelop. Those are the places where I'm usually active the most. So if you have any queries with regards to hackathons or with machine learning, you can always reach out to me. Now, let's quickly sort of walk over the agenda for today's presentation. So, first, we'll be giving a quick introduction to what exactly is MediaPipe, what are the different types of solutions that it has, and then we'll sort of look at a simple example of the Selfie segmentation solution, and I'll be sort of going over what exactly does it mean, and we'll be looking at a use case example of using this particular solution, and then we'll be taking up the question answers from all of you who are attending this particular talk. Now, we know that today machine learning is literally everywhere, right? Whether it's in the field of education, healthcare, or even in factories, right? Whether it's trying to understand the amazing sort of stock market situation that has gone from Elon Musk's tweets, or let's say trying to remove any kind of hate tweets that might be there on a platform like Twitter. So all of these different applications involve machine learning and artificial intelligence in some way or the other, right? And we have a lot of wide variety of different applications, a wide variety of different types of AI based algorithms that you can use today to do a lot of great things. And it has truly been, let's say, the technology of at least this decade, right? And the kind of adaptation that we're seeing in literally each and every different walk of life, you can find machine learning in some form or the other. And that sort of then sort of comes to the point that, is there any effective solution for running these machine learning models in web and on low power devices like on mobile phones? Because generally, if you consider any kind of a machine learning model, because the model has to train over a lot of data, right, in order to be able to, let's say, make a prediction. In that scenario, a lot of times the machine learning models can actually require a lot of compute power, because all that training, and then whenever they are going to be making some kind of a prediction, that does require a significant amount of compute power. But of course, when it comes to running machine learning on web, that means on the client side, right, and or let's say on mobile devices, they might not necessarily have the same kind of compute power that is required, because sometimes for some of the machine learning algorithms, we can literally have like huge servers with dedicated graphics and dedicated CPUs that allow you to run those algorithms. So we need to have an effective solution through which we are able to run some of the more useful machine learning algorithms on such kind of devices, so that we can increase the reach of using brilliant solutions provided by utilizing machine learning in those solutions by collaborations like these, where we're able to, let's say, optimize the machine learning models so that they can be used inside of web and low power devices. And that is where basically MediaPipe sort of comes into the picture, and we will learning about what exactly is MediaPipe and how is it actually related to machine learning, right? So that's what we are going covering, and how it can be used to actually run really great machine learning models on low power devices. Now, if you look at all of these different kind of examples or these images, right, there are certain things that are in common, or basically, if you look at from a perspective of what all different things that you can see inside of this image, right. So the first thing that you'll see, like for example, let's say, on the left hand side we have basically this Android phone, where you can see the faces of the different people who are inside of this frame, they are getting detected. Then we have this iPhone XR picture where the hands, and basically we are creating landmarks on the hands of the person. Then we have on web, we have these special effects that are happening on the face of this lady. Then we have it being utilized on Raspberry Pi by using TPU, that is basically tensor processing unit. And then we also are seeing it in YouTube and also in Nest Cam, which is basically a solution that enables you to have smart security features for your webcams. So all these different things have one thing in common, and that is that all of them are being powered by MediaPipe, right? And we'll be understanding what exactly is MediaPipe and how it can be utilized. And all of these solutions are showing you wide range of different kind of capabilities that you can expect when you try to implement MediaPipe, from detecting faces to having some kind of special effects to even actually using it for security purposes and running on low powered devices such as really small microcontrollers and microchips. And that sort of brings us to MediaPipe, right? So essentially, MediaPipe is Google's open source, machine learning, cross-platform machine learning solution, and basically, it is used to create perception pipelines. What that means is that basically, wherever you have any kind of video-based, audio-based, image-based data, you can create really great machine learning solutions or machine learning pipelines that help you to sort of process that kind of a data, right? And it's used widely within Google as well to analyze a lot of video, audio, and sensor related data. And it allows you to basically create the different types of pipelines through which you can create a machine learning solution, an end-to-end machine learning solution. That means being able to first detect any kind of a data, then analyze that data and then make a prediction. So that end-to-end in like pipeline that involves from analyzing the data to giving the predictions and showing the results, all of that can be handled with the help of MediaPipe. But today it's being mostly used as an open source solution through which you can use a lot of its pre-built solutions for doing a lot of audio, video, and image based tasks that could include object detection, and you're looking at a lot of other different kind of solutions that you can actually build with the help of MediaPipe. And if you look at some of the most core features of MediaPipe, the first one being providing end-to-end acceleration. What that means is that, as I mentioned, right, there is a need for being able to run machine learning models on web and on lower powered devices like on mobile phones. And in that aspect, we have basically a really great solution that is offered by MediaPipe, and that is that all the acceleration that goes on is on device, and it does provide very well optimized machine learning models. So there's not really a requirement to, let's say, have a separate server dedicated for actually the training and for using basically the machine learning models. They can be directly trained, and all that can happen with the help of the device acceleration. Then there's only going to be like one solution that you're going to be building, and those can be deployed to multiple solutions. Now, whether it's a web-based solution, it's Android, iOS, or let's say even for that matter a Python solution. And these are completely ready to use a solution, and that means that you don't need to write a lot of code logic of the actual machine learning that is going on. You can directly just use the inbuilt functions that are being used and directly use them for building any kind of your projects. And again, the biggest one being that these are completely open source solutions. And since we are talking about all these different kind of solutions, let's try to see like what are some of the most major solutions that are provided, right? So the first one being selfie segmentation. Basically, this involves a segmentation mask. So it's a masking technique that is very popular in computer vision, in which it is able to detect your frame wherever you are. And let's say if there are multiple people in a single frame, it is able to detect those and then just remove the rest of the entire background. And then we have things like face mesh. And actually, just to come back to the selfie segmentation, basically the selfie segmentation, like the machine learning model that is being used to power selfie segmentation, is actually being used to also power the different kind of background changes that you see in Google Meet. So as you can see, like basically, MediaPipe is being used in a lot of different Google products as well, including like Google Meet as well. And then we have face mesh, which allows you to have more than 460 facial landmarks across your entire face. And that can actually enable you to do a lot of different things. For example, let's say if you want to try out some face avatars, some face filters, or do a lot of other things, like let's say trying to understand if a person is sleepy by only looking at their eyes. So with the just some simple mathematical logics that you can probably think of, by looking at the coordinates that are there, being provided by these landmarks, you can try to do a lot of different things, right? Then you have hair segmentation that only sort of analyzes your hair and can uniquely detect it. Then we have standard object detection and tracking that are some of the most popular computer vision techniques that are out there. Face detection, hand tracking, human pose, which can probably be used to, let's say, create an exercise buddy, right? You could try to sort of create a solution where you do an exercise and can count how many times of reps are you doing, or it can actually advise you if you're doing like, let's say, an exercise in a wrong way. Then we have holistic tracking that basically combines the face mesh, hand tracking, and the pose to provide an over holistic, like sort of a solution. And this could potentially be used to, let's say, create a VTuber. Today, we know that VTubers are becoming extremely popular, and usually what people who are using VTubers, they have to spend thousands of dollars to get that kind of an equipment, because that is really expensive, right? That entire gear. But with the help of MediaPipe, we can actually create that for free. And that is the power of MediaPipe, right? Then we have 3D object detection that allows you to detect special objects, like, let's say, a table, a chair, right? And like a book or a shoe. And of course, like, these are only some of the solutions, and we have a lot of other solutions that you can actually use. And you can just think of like what kind of applications you might actually want to build with all these different solutions that are readily available for you to actually just go and start using, right? And that is the power of being able to use MediaPipe. Now, if we try to look at some of the real world examples where it's being actually used, so one of them is basically this AR lipstick on YouTube, which basically uses face mesh, and it is able to detect uniquely your landmarks around your lips, and then you can customize basically all the different types of lipstick colors. Then we have basically, for example, AR being utilized inside of YouTube, again being powered by MediaPipe. And for example, things like translation of text, augmenting faces by using, again, face mesh, right? And then being able to actually visualize 3D objects, for example, using the Google Lens. All of that is using MediaPipe. And today, a lot of different companies are utilizing MediaPipe for different kinds of solutions. A lot of health applications are using the MediaPipe Blaze Pose, and like the holistic models to build basically exercise tracking applications that can be beneficial for people, let's say, suffering through physiotherapy, of having physiotherapy based issues. So there's a lot of different real world examples today that are being used. And again, why we are having this conversation, and why we are having this workshop, is that even you can get inspired and try to build some kind of applications like these at Hack the North as well. Now, if you look at sort of the timeline, right? So basically, with MediaPipe, it's not something that was just launched quite recently. It was being utilized in within Google, for almost 10 years now. But although before this, it was being used for some other internal projects, and it is only recently that it got support for creating these kind of machine learning solutions when there's an integration with TensorFlow Lite. So basically, if you're not aware of what exactly is TensorFlow Lite, TensorFlow is a machine learning library, open source library, and TensorFlow Lite is used to basically power right on low powered devices, or basically when you want to do on device machine learning, and that can be handled using TensorFlow Lite. So after that, we started getting basically MediaPipe on things like YouTube, Google Lens, on hardware like the Nest Cams, and then we also started getting it in the cloud, being able to power a lot of different cloud based, Google cloud based, including the Cloud Vision API, where basically MediaPipe is being utilized to run that. So all of this shows that kind of impact that MediaPipe has actually created over over the past few years, right? And now let's try to understand basically how does MediaPipe actually work under the hood, right? Because we have been talking about all amazing things about MediaPipe, but now let's sort of go into a bit more technical depth on how exactly does MediaPipe work. So we are going to be taking an example of the hand tracking, and our goal is going to be that we are going to be taking a single, let's say, a photograph or a live video stream of the hand. And what we would want to do is that we would want to generate these landmarks. Now, for those people who might be getting slightly confused on what exactly are landmarks, so landmarks are essentially these points that represent in a 3D space. They represent the coordinates of the points where we are able to see the actual input being there, and then you can use a lot of different kind of mathematical tools to actually simulate the movement of these landmarks, right? And based on whatever you're trying to build. So when you try to superimpose both of these, you can see the view that we see over here. There is you're having your standard image being taken, and you're superimposing on top of it the entire like the list of the entire landmarks that are coming on this hand tracking, right? So we are going to be looking at how does this actually take place. So essentially, again, what we're doing is that we have an image or a video. So from the video we'll be taking a frame, or let's say if we have an image, then we are on top of it running a machine learning model that is able to generate the landmarks and then superimpose those landmarks on top of the image. But let's try to understand this from a more sort of in-depth sense of what exactly is going on under the hood. So over here, what we're trying to do is we're trying to build a simple perception pipeline, and that pipeline is being able to detect your hand, right, and being able to generate the landmarks on top of it, and that is the desired output that you'll find. So the first step that you'll see at the top is taking up your video, right? That video that you're going to be using, and that is basically your video input. So it could be either, let's say, a video that you share, or let's say it could be from live, right? Then basically what happens is whenever and of course, like, this is going to be quite true for all the different kinds of machine learning algorithms, that whenever you are trying to do any kind of thing related to utilizing your data will always go through a transformation, right? Now it could be a mathematical transformation, or it could be something else, but usually it's going to be a mathematical transformation, right? And in this case, what we are doing is that we are reshaping our size of the input that we actually got to a desirable shape that can actually be used, right? So in this case, what we're doing is that we are using an image transformation where we are changing basically the entire length and width of the image, so that it can be made to a suitable size that can be used by the machine learning algorithm, right? Then what we're doing is that we are using basically a mathematical technique to be able to convert image to tensors. So for those who might not be aware, tensors are basically these n-dimensional or these multi-dimensional arrays that contain certain solutions, and these can be used to basically help manipulate how the data has been transformed into the tensors, right? And these tensors are the ones that will be used inside of the machine learning model. So one thing to sort of keep in mind is that whenever you build any kind of a machine learning solution, it always whatever type of data you might have, like it could be textual data, it could be audio based data, it could be video data, all of that data, like, gets, you could sort of say it in this way, that all of that data gets converted into a mathematical format, because as I've already mentioned in one of the previous sessions, that machine learning is really mathematically focused, right? So once you have converted those images into tensors, then basically we'll be running inference on top of those values with the help of our machine learning model. Then what will happen is that once that inference has been run successfully, we have sort of taken out certain outcomes. So basically what we're going to be doing is that with the help of that, we'll be able to actually visualize our landmarks, right? So basically what the machine learning will do is that you take the image of your hand, it converts it into the size that is required by the model. Once the model treats over it, or sort of trains over it, the next result that you get is basically the landmarks. Now once you have gotten the landmarks, right, that is the next step, that basically the what is essentially the decoding the tensors to the high level metadata, and this metadata is basically the coordinates that you see inside of the landmarks, right? And essentially then what is the final step? That we are rendering those landmarks back onto the image that we had used originally, and the result would be something like this, where you see your original image and also you see the sort of the bounding of the landmarks on top of the image, right? And if you move this in real time, basically your landmarks will also change in real time as well. So those are some of the suggestions, or basically what exactly goes on behind the scenes when it comes to MediaPipe. And just talking a bit more about what exactly and how like all of this is functioning. So some of you, or a lot of you, might have heard about like what exactly is a graph data structure, right? So graph data structure consists of nodes and edges, and the data basically passes through them, and you have different streams set up, right? So for example, it could be related to, let's say, the Bellman-Ford algorithm, or these kind of algorithms you might have probably come across. On a similar basis, we have basically a MediaPipe graph that contains the entire perception pipeline. So over here, essentially, each and every node that we have, right, that is called a MediaPipe calculator, and that is the main brain behind doing any kind of a change or any kind of thing that we want to do. And all those calculations are happening inside of these calculators. Now these calculators are written in C++, and they have basically two different types of you could say entry point and exit point. Basically the input port is where all the different kind of requests are coming in, and basically once we have done that, the output code is the sort of the data that has gone transformation after having been run by the calculator, right? And basically whenever some kind of data enters the graph, it travels from the edges to the different nodes, which are the calculators, and we get our derived path, or the derived solution, and that essentially is what the final solution is. But basically the data that is being sent, that is called as a packet, that basically consists of a stream of different packets that contain the information, and that is what goes into the calculators. So that's basically what exactly does the graph and the calculator sort of personify when it comes to understanding what exactly and how basically MediaPipe actually works. And if you want to go ahead and actually look at more in-depth details on how can you try to understand and try to actually visualize MediaPipe, so you can go to docs.mediapipe.dev to understand a bit more just about the inner working of MediaPipe, and you can also go to viz.mediapipe.dev to try to visualize some of the pre-built models that have been utilized inside of MediaPipe. You can understand how they actually function, right? So this way you can actually go ahead and visualize MediaPipe as well. So that sort of brings us to the selfie segmentation model. Now, I'll quickly just share my screen again, and let's actually go to MediaPipe.dev, and I'll just quickly walk you through basically the selfie segmentation solution and what exactly like what it does and how basically it operates. Right? So let me quickly bring on my another slide. So it shouldn't take a lot of time. Give me just 1 second. And of course, till then, please make sure to keep in your questions coming in. If you are genuinely interested in creating machine learning solutions during Hack the North, this is going to be a really great opportunity without having to learn a lot about machine learning. Or even if, let's say, you are a complete beginner, you can still basically go ahead and use MediaPipe, and to create some really innovative solutions. So I think I have shared my screen again. It should be back to the to this particular, yeah, all right. So there you go, you see another Shivai. So essentially what this particular example is showing is something that we call as the selfie segmentation. Now just to sort of give a bit of context regarding what exactly does this particular solution it does, is that it is able to uniquely identify a human subject, and then it creates a segmentation mask, right? So essentially, if you have, let's say, one or multiple people right inside of a single frame, it will be able to detect all of them uniquely, and able to create a segmentation mask on top of it. So what that allows you to do is that whatever is not part of the segmentation mask, you can just do whatever you want to do. For example, if you want to change, like have a virtual background, you want to blur the background, you want to change something, right? And you can actually just go ahead and do that, right? And while your face or whatever you're trying to detect, that will always remain the same with the help of this particular column. So essentially what we are going to be now doing is we'll just quickly go over how basically this code sort of interacts, and let's say if you were to build a similar kind of solution, how can you go ahead and do that as well, right? And we'll be understanding how the solution works. So basically one thing that we can see over here is that you'll see certain flags over here, and this allows me to, let's say, change between my different cameras. So let's say I can change it to the other camera that I have, and you can see me over here. I can go back to my main primary camera. Then let's say basically I have something called as the effect. Now this effect could be either in the forefront or basically the foreground. The foreground being because it's uniquely identifying and creating a segmentation mask to detect me. Or you can also go ahead and change it so that it what it does is that it does actually the opposite, and that is basically putting the colors and all of this background as the background of the video, right? So this way you can change between, like, let's say background or foreground by just putting this as, let's say, a simple query. And you can also change basically the between different types of models. So basically we use two different types of models. One is the landscape model and the other one is the general model. So both of them are again useful in their own rights. One of them is like, let's say, slightly more efficient in terms of being able to actually share the details. So basically we can go ahead and change between the general or, let's say, the landscape model. And again, both of them are equally useful. Now if we just quickly go ahead and review the code of how basically it functions, right? So on the left hand side you'll see that basically we have just used some simple HTML, right? And we have this defined basically the canvas where our input video stream is actually coming in, and then we are basically using a frame by frame version of that input stream, and rendering it on top of the canvas, right, that you see. And then we have basically a loader that basically waits for the machine learning model to actually load. So it can take up to, let's say, 2 to 3 seconds for the solution to actually load. And then we have basically defined this some details about what exactly is MediaPipe. And then we have some simple SCSS defined, like basically a CSS defined. And finally what we're going to be looking at is that the most important aspect is basically this TypeScript file, right? This file that basically showcases how can you actually utilize MediaPipe, right? For example, let's say if you're creating a web-based solution, right? So the first and foremost, the most important things that you'll have to keep in mind is when building the solution is, of course, you have to import your MediaPipe solution, right? You want to get an input video, right, through which we are able to generate the canvas, right, for basically the video container wherever the video will be present. And then we'll be doing the predictions by first taking out these values. We'll be doing the predictions, and then what we'll do is that we'll basically go ahead and generate whatever is required to be generated as part of the machine learning solution, and that will get generated on top of your canvas. So basically your canvas gets overfilled with the output that you will see. So basically that is the general trend that we are going to be following whenever you want to create such kind of machine learning solutions, right? So the first thing that you'll see over here is basically just being able to support different type of devices. But the most important one for us is going to be three things over here. And first we'll start off with basically the video element that is capturing the main video, and we are basically getting our HTML video element that we are using over here, right? And this is basically showing us the by default it will just show like a simple comment. And we are basically taking the input video, what is the output canvas that where we actually are going to be displaying the MediaPipe output that we get, right? And then basically the control elements that you see over here that help to basically define and understand like how basically MediaPipe sort of works. So all of that, all those control elements will also be useful for changing. Let's say if you do require that between, let's say, the different models, or let's say if you want to do the foreground or the background. And that's what basically we have defined over here inside of the canvas element. Now the next thing that we are going to be sort of looking at is basically loading the actual model itself, right? So basically if you look at from line numbers 70 till 76, right, over here inside this code, you'll see that what is the artifact that we're going to be having, and that is going to be masking. And that is what you saw over here when by default it had actually masked my face as compared to masking my background. So we are going to be using the results that come in from the MediaPipe results, right? Once the segmentation has actually done, and we'll be able to run that. And for specifically for that, we are going to be basically defining our MediaPipe. And over here, you can see how we have basically defined our selfie segmentation solution. So we have simply just gone ahead and defined it as const selfie segmentation, and we are returning basically the npm module that is required for selfie segmentation, right? That is required because that will be used for basically being able to generate the segmentation, right? So we are using the CDN link, and we are able to use this selfie segmentation function to go ahead and actually generate the stats, or let's say to do any kind of application that we want to build with the help of selfie segmentation. So coming back to basically the point where we had basically created this on results. Now this is essentially the basically the function that you can consider that will go ahead and basically analyze the data, and then go ahead and basically uh, run the algorithm, or basically run the machine learning model, right? And be able to use it for certain things. So for example, if we sort of look at from the perspective of, okay, once we have gone ahead and defined our canvas, right? We have gotten our input image, we have sent it to our selfie segmentation solution, right? The results would be that basically, again, the first thing would be that it will sort of wait for it to clear. And then what we're going to be doing is that we are going to be basically going ahead and drawing the image. So basically what we're doing is that on the canvas, if you look carefully, we are using this particular function that is canvas.draw image, right? So what we're doing is that we are drawing an image on top of the canvas, right? And either it could be, let's say, the segmentation mask on the face, or it could be outside, right? Based on whatever value that we're selecting. So this is what is going to be there officially in in basically the draw image function, where we are going ahead and taking the results and going to be basically on the canvas itself. We are going to be adding basically the segmentation mask that you see right now in action. So that is basically when we are now starting to add. And essentially what we're doing is to sort of fill that resultant solution. We are just filling it with this canvas ctx.fill style, through which we are able to just fill. So basically you'll see two of them. One is whether it's a source in or it's source out, and that is the one that is sort of looking at when we are sort of trying to have basically whether we want the effect to be in the background or in the foreground, right? So for example, let's say for the for the background, there will be certain folks who will be using this. Let's say if you want to be basically be used to actually mark your face, it could be used in the foreground as well. So that's basically how we are changing between the styles when it comes to which particular type of source that we want to actually go ahead and use. And we are just doing some basic css work over here to sort of configure this, right? And this is sent. So basically, again, the main idea over here is that we take an input, right? We take an input file, and we use it in the video canvas. We run our MediaPipe on top of it, right? And we are able to generate basically, let's say, certain landmarks, right? And those landmarks are then superimposed on the canvas of the image that was created, right? So there's have to be a temporary canvas that is created to also sort of have those particular things as well added. So yeah, basically that's what is right now happening, is that the model has trained, and it has basically sort of identified where exactly it needs to show the segmentation, and it's like just showing that up. So now basically what the next thing that we can sort of talk about is that once, let's say, we have loaded in the selfie segmentation model, right? So what's the next step, right? What can we do? So then basically we have just defined certain controls, right? That help to basically trigger between either we wanted whether we wanted, like, let's say, one of them or the other one. So basically that can be handled with the help of this from with the help of this toolbar. But apart from this, one thing that again sort of I want to reiterate is that essentially, like, if we just sort of recap what is happening behind the scenes, right, with respect to this particular example, is that again you're taking your input in, let's say, an image, right, and or let's say in a live a video, right? And whatever that information is being handled by the machine learning solution, right? And it is able to generate basically the poses, or let's say it is able to generate the landmarks on top of whatever you're trying to train it. And that again is like really amazing, right? That we can do all of this with the help of MediaPipe. And once you basically get your input, run the any kind of a solution, MediaPipe solution on top of it, and and basically once you run it, whatever kind of landmarks are generated, use those, right? And use them in any kind of an application that you might want to build. So for that, like, we'll be looking at a simple example where I've also created a similar kind of an example by creating a selfie segmentation solution. And again, just to reiterate, this same kind of solution is being used right now in Google Meet, although it's slightly different. But yeah, I mean, it is definitely being utilized. And make sure that you can definitely try to leverage the use of these particular MediaPipe solutions for your own problem. So very quickly, I'll again just jump onto my third screen. So give me just 1 second, and we'll actually go to the actual code base, right? We'll be looking at the actual code base over here. So let me quickly share my screen. Give me just 1 second. And of course, again, if anyone has any questions thus far, feel free to go ahead and ask your questions, right? I'll be more than happy to pick up any questions that anyone of you might be having. So let me quickly just share my screen, and we can look at the project then. All right. So now what I'm going to be doing is that basically specifically for Hack the North, I had created a demo repository, right? So basically this demo repository is showing you an extension of what we just covered, and inside of the selfie segmentation solution. Again, the link for this particular code, you can find it inside of you can find it inside of the GitHub link that is provided at the start, but you can also always refer to it and try to build a similar kind of solution. So I've basically just have some simple starter code where I've just defined like a landing page, and if I quickly just go ahead and look at how does it actually look, right? So this is basically the landing page for the MediaPipe selfie segmentation hackathon solution. Now, of course, what you can see is that basically we'll be going to be having two different type of buttons. One is blurring the background, and the other one is creating a virtual background, right? And we'll be seeing how can you actually do that with the help of this particular issue. So basically we have two different items. Again, we are having a solution that is using, let's say, basically the blur, right? And the other one is being able to change the virtual background, right? So let's actually go ahead and first try it out and see how is it actually functioning, and then we'll look at how can we actually go ahead and build it, right? So for example, let's say if I choose my blur background, so it's taking my webcam from from my mobile, and it is able to blur the entire background, similar to how we're able to blur things inside of Google Meet, or even for that matter Zoom, right? And the next one that we have is basically the virtual background. This allows you to have any kind of a virtual background that you would want to have, right? And you can add it over here. So this is basically how you can go ahead and sort of change between the different views. And now we'll also sort of try to understand how does the code logic for this basically work. So coming back to our code, right? Coming back to our code. Now, the first and foremost thing that we're going to be doing is that we've written basically a small file, right? And essentially what we're going to be trying to do over here is that whatever data that has been provided over here, in this case it being these two particular images of the file, and let's say we basically whichever you click, it will open up that particular segment, right? For example, we do have the blur background as a separate project, and the visual sort of the virtual background as a slight different version of it. So based on the button that you click, you will be able to go to that particular screen. So for example, let's first talk about the blur background, right? Because that is one of the most important. So in this case, like, again, the simple thing that we have done is going ahead and basically having this like output container that will showcase the blurring actually taking place, like we discussed on the canvas. Like if you look at the outer output canvas, like it can show the images and like features. Then if we go specifically to the index.js, right? Now this is where all the all the magic is actually happening. right? From basically taking up, sort of using the on results, where we are taking basically the canvas again, and we're drawing on top of it the resultant image, right? And we'll talk about like how can you sort of use it, right? So basically that is what and how it's being run right now. So again, we are using simply the selfie segmentation solution, right? And we are able to return. Now, basically, what we are also trying to additionally do is, for example, you can see that we are putting up a filter on the canvas CTX, right? And that is being defined in line number 17. That means we can actually go ahead and blur the context of all the different draws once, like, let's say the solution has been chosen, right? And what this allows you to do is that, okay, they can change the amount of blur that you want, and this will have you like give you a controlled environment in which you can actually sort of change the a blur that gives you that blur background, right? So that's another way of actually going at, let's say, using it. And essentially that sort of, then once, let's say, it has been predicted, then it will be replaced, right? But that's pretty much like what how we are using first the selfie segmentation solution, right? And then we are using it to sort of make more changes, right? And we can do a lot of different things apart from doing this, right? But essentially this is the most important thing, and we are using basically the selfie segmentation on results to quickly get the results of all these particular values, right? And essentially what it wants is, right, that whatever different kind of results that it expects, like it will use those on results and try to use them, right? And that's basically what is happening inside of this selfie segmentation, with specifically with the blur background. So again, we just need to start the camera, right? And gain, like, basically, because there's a lot of effort going on, right? So basically we take the machine learning solution, we run it on top of the whatever different kind of things we are having, and then those will work further. So I hope, like, if everyone is able to understand this, you can always again reaching out you can keep reaching out with your questions on top of it, well. And now let's try to sort of look at how basically the virtual background code is sort of working, right? Where we are going ahead and taking a virtual background of our own system, right? So basically the way to sort of do this is, again, for the virtual background, we have just gone ahead and changed, right? Because you can sort of look at the virtual background, and it will have similar kind of properties as, like, with respect to the with respect to basically the other one as well. But when it comes to basically the virtual background, in this case, earlier, like we had seen the example that we were using canvas ctx.fill style, where we were filling like a like an official name. But basically what we are going to be doing over here is, again, we are taking the canvas ctx, right? We are going to be drawing the image on top of it, and use basically, let's say, the segmentation mask, right? And drew like that particular image of what it should appear like. But essentially what we are going to be doing is that, again, the main idea being that whatever is there that is not part of the main view, right, that needs to be sort of changed, right? From a perspective of let's say, based on a particular virtual background. So what we're doing is that we're taking the image from basically the html file. So if you look at our html file in this, right, we'll find a value. So if we go very quickly to the index.html, you can see basically this particular image, that is the like vid, and this one has basically all these values. So this is like an value that we can add. So now basically what we're doing is that, again, we are using the canvas ctx.draw image to basically start drawing on top of the images, right? And in this case, what we're going to be doing is that we are going to be drawing the image from the point where exactly the detection sort of takes place, and from there we can move forward. Now when it comes to basically understanding how this operation is supposed to work, right? Again, the idea is that we'll be taking solution, right? And we'll be again rendering it, right, and using that. But of course, like, this will enable you to try out a lot of different other solutions as well at the same time. And this way, like, what we're now doing is that we are taking the virtual background image that you saw over here, right? And like that you can see over here, for example, in this virtual background. And what we're doing is that again we load our selfie segmentation solution, and as soon as, right, once the camera loads and like we wait for the selfie segmentation to actually go ahead and be utilized, we send the image as the video element, right? And this is what is being sent as the element, and we define its weight and its height, and then we can start using it. So basically this is what we are supposed to be doing, right? Being able to go ahead and use these functions directly, and then going ahead and basically changing it based on what is the feedback, right, that will be required while changing the machine learning solution. But of course, like over here also we are simply using, right, the segmentation solution, and very easily getting on this. So basically, again, let's say if you were to now go ahead and build your own machine learning solutions using MediaPipe, the things that you'll be sort of looking out for would be that once you have defined like which particular solution you want to use, you sort of write that JavaScript code, or for in any particular language, like let's be Android, Java, and Java, Swift, right, or even for that matter some other value, right? And then what we want to go ahead and do is run that solution, right, and run it on top of the image that has been, or like let's say the data that has been prepared, and start using that, right? And start using basically the predictions that you get for your own root cause. So again, like if anyone of you are having any questions, keep them coming in, right? But also one thing to keep in mind is that why have we gone ahead and used the async await for all these different solutions, right? So again, the idea being that we wait for the solution to actually go ahead and launch, and only then we are able to use it. Otherwise it might render an error when we are trying to code. So I hope this also sort of is really important to sort of understand. But of course, yeah, it is to be able to go ahead and use basically that solutions, or basically the landmarks that are getting generated for the own effect. And that is when basically we can sort of look at how it is first getting loaded, and then how we are exposing it to our own data, right? So we are basically using the selfie segmentation on results by sending the results that we have been getting using this particular function. That is the function that is on results, which takes your image, right? It draws on top of the image whatever needs to be drawn, like basically the segmentation mask, right? And we are able to draw it. And in this case, since we use basically the image as our video, right? So basically what we are going to be seeing over here is, since we did start using that, we basically for calculating like what should appear as the frame, right? Because we are taking, like if it's a live video, we are taking frame after frame solution. So what is the actual frame that is going to be used for replacing the by default image that you need? So this way you can create, like let's say, a small application that allows you to have multiple filters, right? It can have things like being able to detect if a person is drowsy, let's say. And again, for all of that, the only thing that you will probably need to do is once you actually go ahead and load, like say, a solution, right? If you're able to generate the landmarks of it, or if you have the values of the landmarks, that can actually be really helpful. So I hope this makes sense. And again, if anyone, if you have any sort of questions with regards to MediaPipe, feel free to keep them inside of your either if you're on Hopin or you're watching it from YouTube, right? And so coming back to basically the example that we had made, right? So again, giving you the ability to either, let's say, blur the background, where we basically change the opacity based on how the values is changing, and again the next one being, right, that we are able to generate a specific let's say the background, right? That is basically having a virtual background. So you can try to utilize the same model to change between the models, change between the same type of model, right? And again, the idea is that basically it is able to uniquely identify sort of people, and create a, like segmentation mask on top of it. So it's up to them, like let's say if it can be sort of revisited, or let's say for that matter it can actually stay. So that is what basically we can think of while building any kind of solutions with MediaPipe, right? And that is what like this particular talk is supposed to sort of also showcase to all of you. And again, let's say if you want to go ahead and build, you can always go to mediapipe.dev, right? this is sort of you'll be able to see basically a theory of all the different kinds of solutions. So for example, we specifically looked at the selfie segmentation solution, right? And that has a given set of values, and like let's say based on like given languages as well, for example Python, JavaScript, and then support for mobile, Android, iOS, right? So it has support for all these different platforms, right? And again, the main idea behind the MediaPipe algorithm, or basically the solutions, is to apply a lot of the pre-built models that used to take a lot of time to basically now start being worked on and being auto populated, right? And basically that will also help you. And of course, like all these different solutions are made, and of course you can always go ahead and look at all the other different types of solutions that are there, because these are just some of them, right? So that is the main goal behind the MediaPipe and how it's being utilized. And of course, as you saw that basically it's literally 40 lines of code that I've written, and even in that, the majority of the code that actually is there is to utilize the canvas element, and probably only we are utilizing at max 5 to 6 lines of actual code that is required. So use basically the selfie segmentation, right? And then we have sort of just gone ahead and changed it. So I hope this also sort of makes sense to everyone. But yeah, that sort of brings an end to sort of the questions. So of course now I would love to be able to take up questions. Now, let me quickly go ahead and share my slides again. So give me just 1 second. But in the meanwhile, if anyone has any questions now, I'll be more than happy to sort of take them up and sort of go through. If like anyone has any specific questions, we can go through that. So let me quickly share back my screen. Let me quickly share it. All right. So that is sort of the demo that we have, and finally, these are some of the great resources that you can sort of get started with. So one being MediaPipe.dev, and the other one being all the different kind of solutions that are there, including the selfie segmentation solution, where you'll find some of the starter code. Let's say if you want to just go ahead and start using that, you can find some resources over there for that as well. And of course, you'll find the link for the repository inside of the description, and it will be shared with everyone as well. And yeah, so that's pretty much it with my presentation. If anyone has any questions, feel free to ask, and I'll be more than happy to take them up. So just wait for a couple of minutes to sort of look at if anyone comes up with any questions. But again, I would hugely recommend all of you to try to use MediaPipe in your solution, whether it could be a web development based program, or it could be an Android, iOS. Try to just go ahead and utilize MediaPipe and see if you're able to create some kind of a cool application, right? And do share that with everyone. And you can also always reach out to me on my Twitter, that is Hodula. So let's see if we are getting any questions. I don't see any questions as of now. Okay, so the first question that we get is, any tips and advice for students to start with MediaPipe, like if you are very new to this? So, San, like again, my primary, the thing that I started off my talk was with that if you're using the ready-made solutions, you don't really need to know a lot of information even regarding MediaPipe. You can directly just use the solution as it is, right? Because these are ready to use solutions. Now whether it's like the pose solution that you're trying to use, or the face mesh that you're trying to use, so that is basically what is sort of going on with MediaPipe, right? So you don't require any kind of prerequisites. Only, let's say, if you know the particular language that is being used for, let's say Python, JavaScript, Java, or let's say Swift, that is being used, right? So if you want to get started with it, you can simply just go ahead and use one of the pre-built solutions, right? Pre-built mesh solutions, and just write a few lines of code, let's say less than 40 to 50 lines of code, and actually create some really cool applications out of it. So I hope that answers your question, San. And just go through the MediaPipe website, give it a quick reading, and actually get to learn a lot more. Right? Of course, there are a lot of different other KPIs, but of course, like these are definitely some ways through which you can just get started with the documentation and how to sort of install and use MediaPipe. All right. If anyone else has any questions, feel free to ask. I see only one question so far. But just as a suggestion, so basically, what different kinds of solutions you could try out at Hack the North. If let's say you want to create like a multi-party, or like let's say a multi-person dancing thing, or let's say you want to see whether you are making the correct dance moves, or you're making correct exercises. You could use the pose one. You could use, or let's say, the holistic model. If you want to try to create some kind of cool filters on your face, you could try to use a face mesh, right? And of course, there are so many other different type of solutions. If that is a requirement, like you can use any of these solutions to create powerful web applications, or powerful low powered like mobile Android iOS development, like so you can use all of this with the help of MediaPipe. So those are also some of the different kind of things that you can start to actually build using MediaPipe. So we are sort of about to come to the final minutes of our presentation. So if anyone of you who might be watching this particular presentation is having any questions with regards to MediaPipe, machine learning, how to integrate MediaPipe, right? And again, you can make sure to ask your questions. And otherwise, I think all the best to everyone who is attending Hack the North. Hopefully we'll be having Hack the North like next year in person. But of course, I hope everyone is enjoying. I think there's still around an entire day left for submitting your solutions. So I hope everyone enjoys and is sort of learning from this experience at Hack the North. It's definitely one of the world's best student-run hackathons, and just experiencing this itself will be really beneficial for all of you. But it will be really interesting to see if anyone sort of uses MediaPipe solutions during their hackathon submission, and I'll be more than happy to sort of have a look at them and see like what different amazing projects that every one of you are actually building. But with that, thank you so much. In case you still have any questions, you can always reach out on Hopin, and I'll be more than happy to help you out.